today, I'm sure you all saw the information about what we're supposed to be talking about today. But if you didn't, then we are going to be talking project management in machine learning. And let me give a little intro on my man Laszlo, because if you have been in our Slack at all in the last year, you've probably encountered Laszlo. He is extremely generous with his knowledge and his help. And I think that you should get an award, Laszlo, for the most answers helped on, or at least commented on, or clarified. Usually, when Laszlo starts off his questions or starts off answering questions, he clarifies everything first so he can really get to the bottom of it. And most recently, Laszlo was part of one of the teams that finished the engineering labs. You can check out the video that we did with him and the rest of Team 3 in our YouTube channel right now. I'll throw a link to our Slack and our YouTube channel in the chat right now in case anyone wants to join and you're not in it. And yeah, man, Laszlo, awesome to have you here.
Thank you very much, Demetrios, and welcome everyone, the 29 participants, great audience. Shall I? How should I start with the introduction?
Let's probably get your full trajectory. Well, I mean, this is the short version of your full trajectory. His claim to fame, I'll just steal your thunder real fast, Laszlo. He worked at Candy Crush. So everyone that was addicted to that game back in the day, Laszlo probably had something to do with it. He was manipulating you through data science at Candy Crush. But yeah, how'd you get into tech, man?
I was just showing my son how to write code in Python, and I was probably at his age, probably at the late 80s or early 90s. And that was the first time I saw code, and I immediately know that that's what I'm going to do in my life. So that was probably about 30 years ago, and I'm still going. So I think it was a good choice. So I studied computer science, Technical University of Budapest, and then did 3 years as a PhD in machine learning from 2002 and 2005, which was the height of the previous AI winter. It was a really, really uncool subject, working in machine learning. And it was a very questionable choice, but I felt that this is so interesting, and there are so rich variety of algorithms and techniques and tools, because obviously at the time deep learning wasn't the crown jewel or the absolute winner what it is now. You had everything from genetic algorithm to all kind of trickeries, rule-based systems, and so on. And when I was running out of time and money in PhD school, I decided to move to London, because there was these hedge funds who were specializing in time series prediction, and my PhD was in time series prediction with machine learning techniques. And these hedge funds who are doing something called Quant research, and maybe that can be an interesting application of my skill set. So I came to London and worked for 2 hedge funds in Quant research. So I specialized in commodities, gold and oil mainly, and wrote all kinds of strategies trying to make money. And it was during the great financial crisis, so it was very interesting time. So I had a front row seat to that problems, and other catastrophes like the Fukushima incident. I think that was in 2010 or 11. That was another big one, which is obviously from a commodities point of view or energy point of view, that's a big issue. And then after 2013, I moved to data science, because that was an emerging subject, and I was always more on the strategy side or the engineering side and the mathematics side and the technology side rather than actual finance, and joined King as a senior data scientist, and I specialized in virality. So it's not just game player behavior, but I also specialize the sending out of those requests. How can you efficiently send out as many as possible without, unsubscribing it? And there are a lot of interesting insights, which is kind of orthogonal to this conversation. But I must say that describing as manipulation is not a correct way to put it.
I'm sorry.
As the company describes it, you cannot anger your users. You not need to give some fun, and then you need to describe of why they feel what you think as manipulation as fun, and work from that. It's a very interesting subject. A lot of connection to like motivation and player behavior and psychology, which is applicable in other parts of the world. For example, in gamification, that's a very interesting subject if it's done right. So it is not purely about making badges or collecting coins or whatever, but it has a psychological underlying current, and you need to tap onto that to create an efficient gamification work. And then after that, I moved back to finance. So I get a request to join a startup founded by MDs from large investment banks. And we had clients, traders at large investment banks. And we were providing them what I can describe as a very expensive Twitter feed. So crawl news from the world, particularly underserved countries from a news perspective, like Egypt or Turkey. These are hard to access news sources because of the local language. Process them with natural language processing tools, and extract the valuable information through human-in-the-loop and active learning techniques, and provide it to traders who make decisions on that, which is also not accessible to you because they are not going to tell you what they find relevant or not, because it's secret. Everything is about what they do is secret. So how do you create machine learning tools with no feedback? That's an interesting product question. And many of the techniques what we are created, and what we are going to talk about today is born there out of necessity of how in an agile, quick-paced startup environment, how can you deliver a product to the most demanding clients in the world.
So basically, you went and you made your millions during the financial crisis as a quant, and you said, I'm going to put my feet up and I'm going to mess around with Candy Crush for a few years. and then you went back and you were working with an investment bank. Now, I would love to know. So I see there's a good chunk of people here. And as always, in case you're new and you don't know, feel free to throw questions in the chat at any moment and I'll get to them to ask away. Because I know there's a lot of things that everyone has on their mind. I'm already seeing stuff coming through the chat we got one from Alex saying, machine learning without feedback. It's interesting indeed. I would love to learn more. So hopefully we can dive into that a little bit. But let's start with how being a quant then influenced what you were doing with the investment banks.
Mm-hmm. That's a good point. For a long period of time, because obviously in a startup you're so close to the coalface that you don't recognize of what are the influences are getting to you. But my boss was a quant as well, so it means that we were in this kind of investment bank-like, desk-like environment. And I realized after I left Arkera is that how much actually our finance background influenced of how we are thinking about machine learning and how we are treating machine learning models. So, for example, I used to say this in the chat, that monitoring, evaluation, labeling, these are crucial problems. And if you think about in finance, this is a bit easier to comprehend, because the money making gives you an immediate feedback on whether you are making money or not. You know, that's a continuous monitoring exercise. And this can be somehow avoided in a less, deterministic environment. You can get away with not removing a KPI or something like that. But in a quant fund, models are never left alone. They are never ready. They are never in a state where you can say, I'm finished with this. Let's put it in the shelf on its own, and I'm just going to monitor it. No, the evaluation, the monitoring, and the labeling exercise is actually just one tightly coupled process that's happening at the same time. And immediately, if you see something wrong, you immediately question whether the model should be replaced by a candidate. You start creating candidates, label new data. Obviously, in finance, this is less of a problem, but in our use case at Arkera, there was a lot of labeling exercises on demand while monitoring the performance of the models. And immediately creating a feedback loop.
So
and
do you think?
that's yes.
Sorry, go ahead. Finish your statement, and then I'll ask this next question.
And this is creating this kind of ad hoc active learning loop, where you connect all of these kind of evaluation steps into one, messy process. I'm wishing to see some kind of product around this. I see companies like Human Loop, for example, in this area, or Snorkel in its area. I must admit that a lot of our processes which we adopted are similar to Snorkel's open source package, so that's a quite old package, but we had our own twist around that and re-implemented it. But it's a very good mind frame. It's called distance supervision.
And well, yeah, that was my next question was, do you think that this is something that can be applied in many different use cases, or is it specific to what you were doing?
I think that's a good question. Okay, I need to qualify my statement, because often there are situations where the modeling problem is relatively stationary. It depends on the business problem, what you're trying to solve. So, for example, you need to justify of why your process is not stationary, and you need to have this kind of continuous update process. For example, you are recognizing cats, they are a cat, they are not evolving at the moment. You are having a relatively stationary process going towards a solution. But if you read news, or if you recognize text in certain areas. So, for example, it's important to know that linguistic features are rarely changing. English language is English language for at least a couple of decades. But the content, what they are talking about, that's different. But again, you need to qualify your statements that start growing into the product mindset. Like, how do you treat your model as a product, where you have influences and feedbacks from the environment and from the business, and then you need to react to that.
Yeah, that's a great point. So one thing that I was thinking about before coming on here a lot was when we talked with Todd Underwood, and he mentioned that there really hasn't been a strong PM that's kind of gone and led the way, who's been the trailblazer for machine learning yet, to say, hey, here's how it's done, like you see in other realms of tech, that they might be outspoken, they may be loved and hated at the same time, but for better or for worse, you have that in other areas. And because machine learning, and especially MLOps, is so new, we don't get that yet. Do you have any thoughts on that whole idea of someone who is potentially highly opinionated and is saying, here's the way forward, here's how we're going to do it, Do you feel like that's not possible because of so many different use cases?
I rewatched Todd Underwood's conversation because it's a great. He's producing very great content. I highly recommend to consume it, both the conversation with you, and he has other these kind of machine learning fails. Both of them are excellent content. He was explicit about MLOps being a product, and I think this is a very important clarification that you need to be very clear, is that machine learning and machine learning operations are not the same thing. And usually from our perspective, or my perspective, or my company's perspective, we are concerned about machine learning. It means that creating models and solving business problems with machine learning. On the other hand, MLOps is the products that are allowing the business to use machine learning. And these are not the same thing. So I am a customer for a machine learning operations product manager. And Todd was thinking about that. And that's a very important clarification, because I think often, because that's both of them are about machine learning, these two is mixed together and they are not the same thing. And these need to be separated somehow organizationally or conceptually to make sure that the person who is doing one of the two is focusing on the right thing, because that's not the same thing. Providing tools to data scientists or machine learning engineers is different than actually solving a problem with machine learning.
Such a good point. And thank you for clarifying that. Even for myself, now that you said it, it's like, oh yeah, that is a very important distinction that I was blurring the lines on even. So let's talk a little bit about the project management in machine learning and the idea. I've heard you say like doing incremental machine learning. And I've also talked at length with a few people like Jet, who might be in here, I'm not sure, but he's a frequent community visitor. And we wonder about the whole idea of if agile and iteration is the best way for machine learning. And I think you have some pretty strong feelings on this. So I'd love to get your take.
Yeah, first of all, traditional machine learning is very waterfall-like. My internet connection is going, so please let me know if you don't hear me. Waterfall-like because you describe it as a collect the data, clean data, train the model, evaluate the model, deploy the model. So that's a waterfall-like steps. You cannot start any step before you finish every single one of them up to that point. And that's a big problem, because most of your energy is spent on data cleaning, but you only get a feedback at the very end of the pipeline when you deploy it into production and start making money. That's when your business problem, you get the first feedback. So it means that you don't have an MVP thinking, and you don't have an iteration thinking. You are suffering all the costs of a machine learning problem or a product upfront, even if it's not going to work out. And this is exactly why we tried to implement iterative machine learning, particularly in natural language processing, which is a massive project space on its own. So it means that you need to come up with a structure that can be improved upon on an ongoing basis, meaningfully. So it means that you can get to an acceptable state, manually clean the rest, and then come back later and then clean up the rest of the other part. And the question is, how do you do that? Like there's a reason why machine learning is waterfall-like. How do you create? You can't just draw a circle-shaped graph and say from now on this is iterative. And this is where we brought in again Snorkel's thinking, and I think Snorkel CEO Alex Ratner put it very well. Is you need to create an MVP, and you need to gather feedback as soon as possible, And with that feedback, you should be able to incrementally update the model. So you need to have a model structure that can accept that feedback. And that's one of the biggest problems in current machine learning techniques is, apart from deep learning, there is no tools that are capable of flexibly incorporating user feedback or problem feedback or insights into the model. And that's why I used to advocate ensemble techniques, because you can say, here is this model, this is the feedback, here is this next model that only react to that feedback, and as a delta, you can regression test against your original data set. And hence, you are not reinventing the model, what would you do in a waterfall-like pipeline, but only incrementally change the difference, and then you can verify to the previous run of the model of where was the changes. Did you actually incorporate the insights into your new model? And you can go on and add more and more components to this ensemble model.
So let me see if I understand that correctly. It's like you're basically trying to get something out as quick as possible to make sure that there's something, right? So in that sense, it is the MVP.
Yeah.
You're getting something out, but you're not cutting corners. You're just making sure that, because like you said, there's a lot of time spent in this labeling process and cleaning the data and all of that.
As in every MVP, you have an idea of what the solution will be. And that solution, MVP doesn't mean terrible. You don't cut corners. You are working with good techniques, good engineering mindset, and deliver a product, which is production quality. It doesn't mean your biggest problem, for example, in a natural language processing context, is you don't know what the problems are. Even if your best attempts not going to reveal you all the problems. And one of the problems what we find is labeling instructions. You are not thinking of all the edge cases. You have some kind of idea. For example, in a fine-grained topic modeling situation, you have a half-page text for the labelers of that's what we mean by, let's say, news about economic activity. While they are labeling, they start giving us feedback on is this article, which category it is in. You either update your labeling and then relabel a lot of text, or you just keep on labeling and then you are creating a data set which is incorrect. But as they are labeling, you are deploying this model into production, and you are going to get a set of labeled articles, model labeled articles, which you can review and say that where are the errors and where are the positive ones, and where do you agree with that? And from that information, you immediately update the labeling exercise. You immediately relabel certain articles. You create a new model candidate and compare the previous model to the new model, whether that's reflected on these changes. And that is what starts creating the iterative
loop
model creation. And to be able to do that, you need an extraordinary strong engineering mindset, because all of these components happening at the same time. So you are training the model while the labelers start labeling on something different, and you incorporate them in the next iteration. Because I think that's one of the most important thing of agile machine learning or lean ML is those components of labeling, data cleaning, model training, evaluation, they are happening at the same time. There are several teams at the moment who are working on each of the components while without synchronization, because that's the only way to break up the waterfall structure, because otherwise you are just having waterfall in a circle, if that makes sense.
Completely. I want to ask one more question before we get to these questions in the chat that are coming through. And so if anyone has any questions, throw them in right now. I'll get to them in a minute. What you're describing sounds like you have to be at a large company or you have to have a large team. Is that a correct assumption?
Okay, our team who was doing that was 4 data scientists, and we had 4 labelers and 5 domain experts and maybe about 3 interns. So it means that these are not particularly large number of people. What we did is a very strong technical culture where all of our code was version controlled, all of our data was version controlled, and we had a very minimal infrastructure. I must admit that that was before the MLOps tools came onto the market. So we pretty much hand created everything what we needed, but probably I would use a couple of products which just came onto the market now to use them. So
to make your life easier. Yeah. I remember in one of the Slack threads, something like this came up and somebody answered by saying like, oh yeah, if we have to label more, we just get the interns to do it. So poor interns out there, if you are going through the labeling part, although we had someone on here a while ago and they were like, I love labeling. That's my favorite part of this. So who knows? To each his own. Now let's get to some questions in the chat. Ben's asking, what are your thoughts on MLOps products helping with product management for ML? Is it an overreach or scope creep?
So product management in MLOps. That's the question.
Yeah, I think the question is around what we were talking about before with Todd Underwood talking about how MLOps needs a product manager, right? And
I definitely think that is a role that should exist. And even in a small startup, in a small startup, probably there is no such a role. There is a hat what you wear, 2 days a week or 1 day a week when you are the MLOps product manager and you need to figure out how to, serve yourself on the other 4 days of the week. But still, you need to be coherent when you are creating machine learning and then solve business problems, and when you are creating MLOps products and helping creating machine learning problems.
And how about products that are already out there that try to reach into this sphere of helping with product management in machine learning as opposed to being an MLOps product? Do you feel like that? I think that's where they were coming from. Is that scope creep?
I don't see it. I don't see ML product management in MLOps particularly different than product management in anywhere else. So my business partner at Hypergolic is a veteran product manager from the finance industry, and he describes these as even machine learning products as standard products. You need to go through the same thought process of clarifying user personas, pain points, and roadmaps, and solving their problems. And I think the newness of MLOps was because this just created like what's the word for this, on its own or organically, and didn't turn up a role for this, as what Todd was saying. And we are talking about Google on this on this manner. But I think now that we are moving forward, product managers will going to train themselves into MLOps and machine learning, and they will going to be able to approach that. And that's one of our mission as a consulting company, to advocate both of these roles. So if you want to do machine learning, you need machine learning product managers and MLOps product managers as well. And both of them are on top of a product team that has owners and where the team feels ownership. So you do need to feel that, okay, I'm an MLOps engineer. I am helping a company to solve these problems in cool and scalable way. And that's an important motivational factor, because it's important not to feel that this is a chore that the data scientists and the machine learning engineers will gonna, throw at the less fortunate members of the team that, from now on you are the MLOps engineer. I think that's a bad way of, you're going to burn out your people, you're going to lose your people if you are unable to put a good message around doing MLOps and good quality ML as well. Because don't forget that there's a lot of performance metrics or success metrics on data science and machine learning, which are terrible. So I'm not quoting them anymore because they are questionable sourced, but nevertheless, these are not. It's not a good place to work where you have a high chance of failure.
Mm-hmm. Great points. I love how you come at it from that side too, the human side and the goal-oriented from the perspective of someone who is trying to advance their career, and that's not going to be useful for your business if you're not getting that. Now, let's keep going with some questions in the chat. We've got a great one from Alex, and then I see one from Ron. So I'll ask the one from Alex first, which is more of a statement. In the messy world of startups, due to the big upfront cost of an MVP for NLP, it is RegEx. So that is a tongue twister right there. Alex, thanks for making me say that. So basically, which means to get user feedback, or which means user feedback gets incorporated by tweaking the RegEx. So if you got totally lost on that one from me digressing midway, I'll say it again. In the messy world of startups, due to the big upfront cost of an MVP for NLP is RegEx, which means to user feedback gets incorporated by tweaking the RegEx. Does that make sense to you?
I can only quote the classic on this one, is that I had a problem. I tried to solve it with the RegEx. Now I have two problems. My opinion on that is, especially recently, I think with LNAI and Hugging Face, some of the advanced models are in so easy to use and easy to deploy that the barrier in natural language processing is much lower. So you can have an MVP with top quality models out there relatively fast, and then you can iterate around that.
Excellent. Next one coming from Ron. He's got a few actually, but this one is awesome. Does the ensemble model weigh more recent models more than older models? If so, what is the decay rate of weights for older models?
That's a good question. I would think that this is problem dependent. Usually, because we worked in natural language processing, our problems were stationary. So it means that most of the ensemble components that came out later was something what we didn't think about. You didn't think that, a particular way of writing something is different, or in a language other than English, something, if it gets translated, there is some kind of situation which needs to be treated separately. So it means that we kept always the old versions, but these are part of the ensemble structure. We advocate using TensorFlow for even simple ensemble models. So linear models should be in TensorFlow as well, and treat TensorFlow as a programming language, which helps you deploy a single model as an ensemble. So it means that you don't need to think, you don't need to ask engineering that you actually have 2 models, 3 models in production and then combine them somehow. And that's part of our good communication and low friction collaboration framework, where you help engineers that you need as little interaction from them to solve your problems as possible. So that's how we solved in a small startup of not needing to wait for another sprint for our ensemble model to be updated with some kind of gating mechanism every time we change something. We simply gave them a model and they put it into production, and that was it. And the entire ensemble was in production immediately.
Oh man, we're not going to get through this hour without me asking you to explain why you do not like using Jupyter notebooks, but not yet. We've got another question from your teammate Artem. Shout out to Artem, who is here with us right now. He was another one of the finishers of the recent machine learning engineering labs that we did. So he is asking, since the iterative management model is generic enough for most ML projects, which components of it can be easily generalized and tools built? Example from software development world, Git for version control.
I think by far the hardest part of this process is creating the actual model and making sure that it's in the right format. Even if you are very proficient in TensorFlow, that's the hardest part. So I would think that easier model creation or maybe code generation with TensorFlow will be a trend, and I see a gap there.
Okay. So we've got another one from Konstantinos asking, speaking of topic extraction, what type of model do you train for that task? May I guess, Hugging Face or other BERTs?
I think we used some transformer-based model, but it was custom made because at the time we had one type of model which we used for everything else. But now I would use something like Hugging Face. Probably that would be my go-to solution, knowing that maybe that needs some kind of customization if you want to go on your own. But you can also have good results with something like naive Bayesian models and an ensemble of them or other techniques.
Excellent. All right. Last question, and then I'm going to jump into a few more for myself. Being the egotistical maniac, that I want to ask some questions too here, but this one is a great question. What can PMs with a more traditional agile background do to learn to manage machine learning products better?
I think in the coffee session on our lab, this point came up of how non-machine learning engineers or non-data scientists should relate to machine learning. And I think it's relatively easy to get a good working knowledge that makes you stand out of PMs or non-professionals, because currently the zeitgeist or the public knowledge of machine learning is so hype driven that if you have some kind of practical knowledge and let's say you shadow some machine learning team for a while or MLOps team for a while, you can grow quite quickly into quite good position, because as I said, we are still talking about product management with its own techniques and concepts. So the product manager is not a machine learning engineer. He needs to be aware and converse with them and be open about their solutions and solve their problems rather than actually himself doing it.
Yeah, and I see one from Alex in the chat saying that PMs with experience leading ML products are so hard to come by. Do you feel like that's something that you have to have as a prerequisite, or you can teach someone?
I mean, that's the reason why our company specializes in this area, because we recognize this as a critical component to have successful machine learning. You need to bring together several parts of the company and then successfully deploy a project. And I think there is going to be more movement around that and more content. But this is really just starting. So since I'm writing my blog about it, I get a lot of feedback of, there should be more of this content. There is so rare that you have machine learning content from a business side, but not, let's say, TensorFlow code or code examples, also purely technical side.
Exactly. And if anyone wants to follow Laszlo on his blog, on his Substack, you can check that out. I'll throw a link in the chat and we'll have it below in the description. Definitely do that. He's got some fire material that is coming out. You also have a free ebook since we are doing a bit of a commercial break real fast. We'll put a link to that too. What's the ebook about? Just so everyone knows.
Its title is Machine Learning Product Manual. It is essentially how to set up the structure, what we were just talking about.
Okay, perfect. So moving on, let's talk a little bit about the differences that you've seen between academic and real world. I don't know if real world would be the right one. Industrial ML.
Industrial, yes. I think that's a very important distinction, and the roots of machine learning is in research, R&D, universities. They have their own unique constraints and unique priorities, and a lot of the large scientific groups, even in Google or Facebook, are very academic-like, and that's not like in industry. They are. It's not good or bad because they are achieving their own goals, namely get published, create state-of-the-art models with the resources what they have and the constraints what they have on a short period of time, often alone. I think that's one of the biggest problems is data science is thought as a singular activity. You are thinking about solving all of your problems alone, which is clearly not true in an industrial setting. If you need, if you have $100 million problem and you need 100 people, the company will going to hire it for you. That's an organizational problem. If you need expensive engineering kit and a lot of engineers, the company will hire it for you. The question is, how do you use that resource and how do you solve your problem? But on the other hand, state-of-the-art doesn't mean good quality from a business perspective or feasible money-making solution. You need a technique that closes the gap between feasibility and state-of-the-art, let's say state-of-the-art, or the best model that's possible. And that, again, is an industrial question. If you need like a last mile labeling or a last mile human check, like in fraud detection, that usually happens there. If the model is unclear, they're going to route it to a person who makes the call. These are the industrial questions, but these are absent until now, and a lot of people are finding it in an ad hoc manner, or just stumble upon into this one, or they're actually just having very good engineering and conceptual grasp on this whole thing, and they execute themselves. There are a lot of startups in London or fintech startups who have very good engineering culture, and we are regularly get ideas from them. I'm sure a lot of them are here in this community as well.
Well, you bring up a good point that makes me wonder, and maybe it's a question that we can send out to everyone that is here with us right now. And that is, as a data scientist or a machine learning engineer, do you have a strong aversion to going into product management? I feel like there's a lot of data scientists that just want to stay in data science because that's where they can cut their teeth and they can be working on the coolest stuff. So let us know in the chat if you are like, oh, hell no, I'm never moving into product management. That just seems like a beast that I don't even want to tackle. Or if it's something that you feel like it is a natural career progression for you. Because I want to say that you get a little bit of that with software engineers too, right? There's the software engineers that enjoy being software engineers. They're content there. They're not going to want to try and move on and move up the ladder or go into different pieces because that's what they like doing. And that's totally cool. Like you said, it's not good, it's not bad. It's just the way it is. So looking at this as there are all these data scientists and machine learning experts that could potentially have a large impact as a project manager, would you do that? So we've got some people are saying, yeah, maybe I'll get there with age. If I can pull it off like Elon Musk and do everything, yes. Project management is cool, but I'm on the MLOps side, not the ML side. Sweet. So cool. Good feedback there. Now, we've got another amazing question, and then I'm going to get to the question of the day as to why you hate Jupyter Notebook so much. Wait, before we do that, Corey's throwing something in here. I think there's a place for product management for those that have been engineers, data scientists. However, there is the capability of managing an ML product, but then there is the case of having a vision, which is an existing gap across the board. Ooh, good point, Corey. Very good point. So let's talk about this question that just came through. Would you say that ML models as a product have such a short effective lifetime that a product manager should focus more on selling model use with a subscription to a year's worth of model updates instead of trying to sell individual model builds? Ooh, another great question.
I disagree with this point that the models themselves might have a short lifetime, but the machine learning product as a product doesn't. And I think this is one of the core concepts of machine learning product management. When you are solving business problems, the business problem is going to stay there. And you end up using machine learning because you ran out of other options, because you know that problems of machine learning is hard. So if the company decided that this problem, we can't solve it with software engineering, it's too expensive to outsource it to do it manually, we need to solve it with machine learning, you already signed up to the pain. But that business problem is there. So it means that they need to maintain these models on an ongoing basis, more or less resources required on an ongoing basis, but you still need to maintain it. So I think that's one point. The other point of selling these models is what we found is your unique circumstances is so impactful to create a good machine learning model that you need a customized solution. And this kind of API-driven solutions with one size fits all, outside of a very small circle, let's say translation, that's one of the examples. But is not going to work. And I know this for a fact that we tried every kind of commercial offerings on named entity recognition, and none of them worked to the performance that we wanted. And it's very hard to improve a performance on an API-driven, SaaS-based machine learning product.
Well put. I like it a lot. Let's talk more about this question of this one. Oh my God, let's see if I can get this one out. This is confusing as hell, Ron. So, but I appreciate you asking the question. It's just, let's see what he says here. Can you talk about the difference of using data science to inform and product managers decide what product to make versus product managing data science as a product?
Good point. It's almost the same thing. I would think this is almost fused together because data scientists or product managers, they are not project managers. It's very important to distinguish these two things. It's not create these models and then the team is disbanded and then you go on and do some other project because that creates orphaned products. So it means you are creating models that no one is looking at. So it means, or you create this kind of pipeline when you throw it over the fence and then you let some other team solving it. You're mute.
Oh, sorry. No, keep going. Keep going.
But the point is, the product management, when the business arrives to a difficult problem, but expensive problem that needs to be solved, and decides that it needs to be solved by machine learning, the product managers are there in this kind of scoping situation to figure out whether machine learning will be the solution for something. And that's one of the services what we do as a consulting company, to figure out that actually, because often we are meeting with companies who are not having any machine learning operations. So we need to point them out that this problem, what you are having here, is a machine learning problem. You just don't recognize that. And that's what ML PMs do. They find you problems to solve, and then the business can decide whether this is relevant or not, or it's on the roadmap, or they can do it later or something like that. But nevertheless, the ML PMs can help the business finding problems that are solvable by machine learning.
And how do you feel about this, like, I guess, stigma, or maybe not a stigma, just the hype around ML? Maybe people who are not so clear on what ML can solve, they try and throw it at everything. Is that, again, where you need a strong project manager to be able to say, no, this is not a project that can be solved or should be solved with ML?
Yes, that's a very good point. There is also the hype-driven, where you think that certain solutions are solutions for everything. Like, for example, chatbots are the classic example. For a couple of years, everyone was developing chatbots for every solution, to various successes, to remain optimistic. But that's definitely the PM's job to scope out and figure out of the value what a machine learning will going to add, the risks what this adds, and the cost pipeline, or how much, when the project is actually going to run, how much cost it will going to cost, what kind of benefit it's going to create, and that iteration, what I was talking about. The period when a machine learning product can be unprofitable is very short. So it means that you kind of very quickly need to reach that. And that requires good assessment about what are the costs of, a false positive or a false negative, or the statistical errors in the model. That is part of a ML PM's job, hence connecting business to the data science world. So math to finance.
Excellent. Let's get into this Jupyter Notebook showdown. Let's take one of these comments from the chat real fast from Alex, who's saying, if we're going to chat about notebooks, it seems like notebooks, for all their flaws, are here to stay. It is time for the anti-notebook crowd to rally around solutions that address some of the flaws, like Jupytex for get differable notebooks and Netflix's paper mill approach, separate pre-run source notebooks and post-run artifact notebooks. Thoughts?
Okay, I don't hate notebooks. Let's be clear about that.
Come on, well, I don't know, man. There's a lot of posts in the chat or in Slack that could.
I put it this way: Neil Lathia at Monzo expressed this correctly. Is notebooks are whiteboard. It means that you don't want your whiteboard to be your output, because it's a draw, it's a sketch of your solution. You would like to have it a more purest way, your solution. And I can explain how we were using machine learning notebooks in our previous company. Essentially, we used it as an advanced spreadsheet, which the pipelines were creating the data that needed to be analyzed from a label data perspective, statistical analysis, exploratory analysis. We load the data into notebooks, into data frames or some kind of better format and then plot them. But we stopped working there because writing your main body of code in notebooks is difficult. And it's much easier if you pick up the right engineering skills and do even exploratory data analysis or development in Python scripts. That needs to come back to the performance requirements, what we were working on, which was very high. It means that when you say exploratory data analysis, you think that it can be done in a notebook. But for us, exploratory data analysis required large machines, which were crunching through hundreds of gigabytes of text to find out insights that we haven't thought about before. So exploratory can mean large scale as well. And that's unmanageable in notebooks. So we are launching, parallel processing jobs to crunch through hundreds of gigabytes of text and find us something to change in the next iteration.
Excellent. I'm glad you clarified it for all of us. We now know. And for everyone that is still sticking around, I want to thank you for staying. Laszlo is in Slack. He is super generous with his wisdom. Reach out to him if you want to continue the conversation. And don't take any offense if he gets on your question and wants more clarification. You can tell he wouldn't hurt a fly, and he is a super smart dude. So, Laszlo, thanks so much for doing this, man. This has been a long time coming. You've been in the community being like a very vocal piece of the community and a pillar, I would say, with the way that you share and the way that you help everyone. So thanks again for all of your help. And thank you, everyone, for listening. This was awesome. There were some great questions coming through.
Thank you very much. It was likewise great, and I'm happy to contribute to anyone in the Slack. Please just reach out to me, primarily in Slack, but you can find me on Twitter or LinkedIn as well. Thank you very much.
And go check out Laszlo's tool. We'll leave links to everything in Slack and all of that right now because I'm not going to be able to pull it up quick enough. But Laszlo's tool or Laszlo's Substack or anything that Laszlo's doing, the free ebook. And that's it for today. Thanks, everyone, for sticking around. And thanks for the great questions. We'll see you all next week or in Slack.
Thank you very much, guys. Goodbye.